Welcome to this explainer. Today, we're going to demystify AI training in exactly 4 minutes. And how are we doing that? By using a super simple, totally relatable analogy, baking the perfect chocolate chip cookie. Let's dive right in.
So how does a machine actually learn? How does it go from this chaotic, blank slate, literally just a bunch of randomized internal settings, to making those highly accurate predictions we rely on?
To answer that, we've got to step into our AI kitchen. Section 1. The raw ingredients.
Think of an untrained model, like having all your baking ingredients and oven dials sitting right in front of you, but absolutely zero recipe. If you just guess randomly, you're going to get raw dough or, worse, charcoal. But training data changes all of that. It acts as vital feedback from thousands of taste testers, telling you what actually works.
Basically, AI training is just the foundational process of aligning those randomized oven dials. The algorithm iteratively adjusts its internal parameters, what data scientists like to call weights and biases, to minimize errors based on massive data sets. It's all about turning that raw dough into a functional, working model.
Section 2. Baking the perfect cookie. Let's look at how this builds into an actual learning loop.
It really boils down to a rapid 3-step cycle. Step 1. The model makes a guess. It bakes a trial batch. Step 2. It uses a mathematical loss function to measure the error. Basically, it tastes the cookie to see exactly how far off it is from the ideal target. And step 3, it uses backpropagation to slightly adjust those parameters. Tweaking the oven dials for the very next batch.
But here's the crazy part. It doesn't just do this once. This iterative process involves calculating literally billions of mathematical operations across billions of parameters, over and over again. Because of that staggering scale, a standard home oven just isn't going to cut it. AI training requires highly specialized hardware. Think of it as a massive, industrial-sized kitchen powered by clusters of GPUs, so it can bake and taste millions of trial batches all at the exact same time.
But there is a major pitfall in this high-speed baking process. Section 3, the memorization trap.
Our absolute ultimate goal here is generalization. That means learning the true underlying rules of baking so the AI can bake anywhere. But the total disaster scenario? Overfitting. This happens when the AI merely memorizes the specific humidity or the exact butter brand of one single kitchen. Move it to a completely different kitchen, and the recipe just fails.
So, to prevent this memorization trap, data scientists use a clever technique called regularization. This basically constrains our digital baker. It stops the model from becoming way too flexible and memorizing random noise, forcing it to prioritize broader, repeatable patterns instead. Which brings us to what happens when those perfect dials are finally locked in. Section 4, the final recipe.
There's a really stark difference between training and inference. Training, that process of finding the recipe we just walked through, is expensive, it's slow, and it's computationally heavy. But inference? That's the deployment phase. It's when a customer actually orders a cookie. You just bake it instantly using that final recipe. It's cheap, incredibly fast, and requires absolutely zero trial and error.
But before you take a bite, we have to remember the golden rule of AI data. Garbage in, garbage out. The accuracy of the final recipe directly mirrors the quality of the training data. If your initial taste testers had a really strong preference for extremely sugary treats, well, your final recipe is going to systematically amplify that exact preference.
And honestly, this really highlights the strict limits of AI knowledge. These models are, at the end of the day, just mathematical association machines. Our AI baker doesn't actually understand molecular chemistry. If you suddenly ask it to bake gluten-free bread without any prior training data, it'll completely fail. It literally cannot reason outside of what it was explicitly taught.
So I'm going to leave you with this final, somewhat provocative thought. If the AI is essentially just a baker blindly following dial settings without any true understanding of what a cookie actually is, how much authority should we really grant to its final recipe? Thanks for joining me for this rapid-fire explainer, and keep questioning the data.